my God, a real-world meetup. Woo! I'm so excited. I'm just going to ask something before I start. Have any of you heard about synthetic data? Oh, wow! That's amazing. Have you ever used synthetic data? That's also amazing. I'm going to ping you afterwards to ask you some questions. Okay, so like Kostya said, my name is Lotem Peled-Cohen, and I'm a machine learning product manager at Datagen. Thank you so much for having me here. I have about 15 minutes to talk to you about breaking the annotation barrier with synthetic data. So what do I plan to cover in these 15 minutes? I'm going to start with a brief overview of annotations. What are they and what is the classical way to obtain them? And in the second part of my talk, I'm going to have a running example of a computer vision task called landmark detection, through which I hope to exemplify the power of synthetic data and synthetic annotations. And of course, I will introduce you to Datagen's product. There will be time for questions in the end, so if you have any, please remember them. Okay. Opa. Okay. This is the first talk of the meetup. So to kick off this meetup, I'm gonna give a quick disclaimer. In the next couple of hours, you're gonna hear a couple of words repeating quite often, and these are labels, annotations, ground truth, maybe labeled data or unlabeled data. So it only makes sense to start this talk with a brief explanation of what these are. Okay. So in the world of machine learning, we like to separate between supervised learning and unsupervised learning. Can I move a little bit over there? Can? Here? Okay, perfect. In the world of machine learning, we like to separate between supervised learning and unsupervised learning. Supervised learning, as the name would imply, requires some sort of supervision. So, for example, instead of receiving only input data, such as images of apples, the model also receives some sort of annotation alongside that image, right? So the model will receive an image and a label that says apple, or an image of a banana and a label that says banana. Once the model sees enough of these couples of input and annotation, the model will learn the connection between the two, and given a new image, for example, of an apple, the model can provide a prediction. Once the model provides this prediction, for example, apple, we can go back and compare it to the original annotation or ground truth. Okay? So for the remainder of this talk, if you hear labels or annotations or ground truth, I mean them interchangeably, only for the purpose of this talk. Okay, great. So we have supervised learning, but we also have unsupervised learning, in which the model is not exposed to annotations at all. The model only sees input data, for example, images of different fruit, but it will never know what an apple is because there are no annotations. Okay? The model will see many of these images, and in the end perform some sort of maybe clustering technique or something like that to cluster together the categories that look alike, such that given a new image of an apple, the model will know to tell us which category is the most relevant, but it will never know to tell us apple, because it has never been exposed to anything like that, okay? So given that we are here to talk about annotations, I'm going to completely disregard unsupervised learning, talk only about supervised learning, and specifically about annotations, okay? Cool, so this is a very simple, straightforward task, a fruit classification or apple classification, how you would like to call it. And, you know, accordingly, the annotations are very simple and straightforward, right? Each and every one of us can sit with a bunch of images of fruit and write apple or banana. If only it was this simple with other computer vision tasks or machine learning tasks in general. Things are not always this simple, and let me give an example. Let's talk about a computer vision task called landmark detection. In the task of landmark detection, the model receives as input not an image of an apple, but rather an image of a face. And the output, the prediction that the model needs to give, is a list of key points that correspond to important landmark on a person's face. For example, eyebrows, lips, eyes, contour of the face, etc., etc. This is an important task for other larger tasks in the world, for example, of autonomous vehicles. If you want to estimate whether the driver is looking straight ahead or not, pose estimation is built very strongly on landmark detection. Other tasks such as detecting where your lips or eyes are to place a filter of makeup in Instagram, for example, or expression detection to see if the person is smiling. This is a base task for a lot of real-world applications. Okay, if we want the model to predict a list of key points, those are the annotations that the model needs to receive. So this couple that you see here, we need pretty much the same 100,000 times, okay? Who is the magician that is going to sit next to 100,000 images of faces and manually annotate dozens of key points per image? It's insane, right? Which kind of brings us to the point that collecting annotations is difficult, right? Where do I get these labels? How much will they cost me? What do I even request of the annotators? Are these key points, are these annotations noisy at all? So now that we see that this is a really, really, really difficult task, it makes a lot of sense that the market for annotations is growing insanely fast. I'm sure we will hear more from Olga about this later. But services, companies, and tools for annotation is something that we see more and more, with the market expected to reach $10 billion in the next couple of years. And until now, the go-to solution was humans. And that makes sense because it makes sense, right? And humans are doing a wonderful job, right? When it comes to tasks that are straightforward, where the labels are clear and well-defined, like I talked about an apple before. And additionally, of course, humans have the superpower of being human. So any task that involves sentiment or humor, sarcasm, or those types of more human elements, I don't think a bot will ever be able to annotate automatically. So my point here is that human annotations will always be needed. However, human annotators have their own challenges, right? So when the labels are starting to get fuzzy or a little bit less defined, you can see a lot of disagreement between human labelers and a lot of noise. Sometimes the labels even look subjective. If you ask a couple of annotators, they will give you their own opinion, where you can also meet biases. Of course, humans have their own limitation, like they can't label what they can't see, and I'll get to that in a second. And it's very, very difficult to obtain human annotations at scale. But it's possible. Okay? So if you go online and you search for a couple of data sets for landmark detection, you will find them. And there are big data sets out there where humans annotated tens of thousands of faces with key points. Okay, and you can see the link here. I'll share the deck afterwards. And now to the interactive part. How do these look to you? Oh, I heard someone going, meh.
The right picture is a little off. The rest are like sort of okay, but also not
Okay. They look like a heart. Like they all look like hearts.
Okay. Did you hear the answers? Okay, one answer was they look a little bit off. The other answer was that they look like hearts. In general, what I want to say is, first of all, we all have opinions, and even the fact that we don't know if this is a quality annotation says something about the complexity of the task. But in general, I see a couple of things here. So you can see that for this girl's annotations, the eyebrow ends in a very different place than in the other two images, right? Her eyebrow, the last key point of her eyebrow ends almost at the hairline, and for the other guys, it doesn't. Okay, it ends at the end of the eyebrow. Additionally, I can also see that, like you said, some of the points are floating away from the contour of the face, right? Can you guys see that? Okay. So what I'm trying to say is that we can never estimate if these labels are good. I mean, we can, but it's very, very subjective. Yes, question?
These features kind of look like you could use sift features to see changes in the color gradient, and then the annotator can just adjust the existing points.
Okay, I'm not sure I know what sift features are, but if you are referring to a connection between the human and the background in order to detect the edge of the face, I can raise you by saying, okay, choose a very dark person and close the lights. It's a hack, it's a good hack, but there are always edge cases. Okay, second problem is the fact that humans can annotate only what they see. A lot of data sets, in order to raise the complexity, will allow humans to have some sort of occlusion on them. For example, some of you may not be able to see my mouth because of the mic, right? So how can you expect a human annotator to annotate that this lady's jaw key points through her hand, right? But the answer is that they do, and they do it in an off way that completely throws off the models. You can see here some of the mistakes that the model made in those lines. Any types of occlusions are difficult for humans, which makes perfect sense. Know this on humans. And one of the places where it's the most painful is when the person is simply looking away, which is, like, it makes a lot of sense, right? You're gonna have pictures of people looking away. The human annotators usually annotate the end of the face, the contour of the face, based on what they see, rather than where the person's face actually ends. Make sense? Okay. Now, when I gave a dry run of this talk to a couple of people, they told me, fine, just do it in big numbers and the error will you know, like in large numbers, it's gonna be fine. But we all know that neural networks are sensitive beings and that even the smallest amount of noise can make the model think that it's not a banana, but rather it's a toaster. So I know that the errors may seem small, but in large numbers, they kind of become bigger in the end. Okay, good, so far so good. Now imagine that with one click, you could get pixel-perfect key points. So not only get a lot of data, but also get it precisely annotated, okay? This is one of the places where synthetic data can break the annotation barrier. Now, I was also asked that question. All of the images of synthetic people that you are going to see right now are generated by the Datagen's platform. No cherry picking, really. Okay. So I'm gonna introduce Datagen's product right now. Datagen is the leading company when it comes to generating synthetic data for computer vision revolving around humans. So faces, full bodies, and humans interacting with a scene, for example, driving. The Datagen platform allows computer vision teams to just log on and specify what they need in their data set. So you can specify any distribution that you're interested in when it comes to ethnicities, for example, camera angles, lighting conditions, et cetera, et cetera. For the guy who said something about the lights, Datagen's platform can actually help you create these very dark people and very dark lighting to kind of see if your model gets confused. So not only can you create a large data set, which is very, very varied, but you also get it fully annotated. So as part of Datagen's product, you don't only get the face, but you also get a huge suite of annotations together with it. So for example, for each identity that you are going to generate, you will automatically have key points, bounding boxes, eye key points, depth maps, segmentation maps, gaze vector, et cetera, et cetera, et cetera. Okay? Questions about this? Yes.
Does it only work on synthetic generated faces?
Do the annotations? Okay. The question was, do the annotations apply only to synthetic faces? At the moment, the answer is yes. Hopefully within a year, I'll answer differently.
Okay.
Okay, cool. So now we have annotated data, right? Just like that. Oh, another question.
Couldn't we just draw the points of annotations on the face of a human being or a puppet head, and then take photos from all around it, like you see on products of the 63 degrees, and then allow the computer to see the puppet head if already the annotations on it.
I'm not sure how to answer this one because I think what you're asking is how otherwise you could collect annotations for landmark detection? I assume you can. I assume you can, I'm not sure. Of course, there are a lot of ways to collect annotations. I'm just saying that this is one of the easiest ones. And also here, I want to emphasize now two strengths of synthetic annotations that I hope will show the power of this tool. The first one is being pixel perfect, okay? Each and every identity that you generate through Datagen's platform is based on a physiologically correct 3D model of a face. Okay? Each one of these identities has a 3D model behind them. And the key points that we designed correspond to specific places on the 3D model. This means that point number 45 will always fall at the end of the eye, no matter if this person is big or small, and if it's in the dark, and if the person is looking left. Point number 45 always specifies the end of the eye. Okay. What's the beauty in this element is that there is no inconsistency, right? There is no confusion between labelers, and you can guarantee that when you use these key points for certain expressions, you can do it without the fear that the noise will throw off the model. Okay? Another thing that's beautiful is that you can select the number of key points that you want. There's a couple of standards for key points. There are dense key points, etc.
So to generate the faces, didn't you need a model to begin with?
Yes. A model, like a person model.
And that's different, is that different from an annotation model?
Okay, that's a perfect question. Yeah, the question was, did we need a model to annotate? You meant a machine learning model.
To generate 3D faces, I guess you need some sort of model. Physical face model to begin with.
There is a different technology that relies on machine learning to generate these 3D physiologically accurate models, yes. But that doesn't, I mean, it only takes you to the step where you have the faces, and the rest of the labels is another layer in the technology. But yeah, we also employ machine learning tools that also need annotations. No free lunch. Okay. Yes, of course. Okay, so the first thing is the pixel perfect, no noise agreement between labelers, because it's all one labeler. And the second thing, as I mentioned before, the occlusions, right? Because we model these key points based on a 3D model, it doesn't matter if the person has glasses or a cigarette or a beard, right? Knowing the facial key points under a beard is something that is super useful for applications of cosmetic companies, right? Want to know where the face ends, where the beard begins, and those types of things. And last but not least, with synthetic annotations, we can tell you which key points are visible and which are not. So in this image over here, with the guy closing his eyes, you can see that his nose, the red key points on the nose, are not visible to the camera. And this is very, very valuable for the task of pose estimation, because I can know which key points are occluded. Right? Okay, great. Now, as I mentioned in the beginning, I don't believe that human annotations are going anywhere, right? The beauty will be to mix the two. Now, real-world annotations, as I said, they have their beauty in the fact that they are noisy, but synthetic annotations have their beauty in being clean and kind of normalized. Okay? So actually, our algorithmic team, and specifically Roy Ron, in case you know him, wrote a beautiful paper on how to combine synthetic data, specifically synthetic annotations, in a way that makes sense and really improves their models. I'm giving here a couple of examples of things we did. For example, match the distribution of image size, because the image sizes in the real-world data and synthetic data didn't always match, or performing some sort of label adaptation, which means adding some noise to the perfect synthetic annotations. I don't have a lot of time, so I'm just going to encourage you to read the model and answer when I finish. Remember the question, please. Okay. And this was only about landmark detection. There are so many other tasks that can benefit from synthetic annotations. Pretty much any task that has subjective label definition with a lot of disagreement, and any task that can benefit from a 3D model of a face, for example. This is an example of a task called gaze detection. Again, to see whether the driver, for example, is looking straight ahead. The green and the red are two different annotators. Okay? So with a single 3D model and synthetic annotations, you will not meet this disagreement. The same goes for facial segmentation task. Great. And those are only the tasks. I haven't even begun to talk about scale. The ability to generate tens or hundreds or 100,000 of humans that are annotated out of the box in a pixel-perfect way is just invaluable, especially since you can specify the variants that you want and mitigate the biases that you need, like the dark person in the dark room, where your model failed, okay? And last but not least, Datagen not only offers human generators, like facial generators, but we also create humans interacting in a scene. Kostya presses play. This is this is a video, a sequence of frames that shows a woman falling asleep at the wheel. Okay, this is part of a generator, a new data generator that we have released that creates these snippets of video. You can press play, I think. Okay, perfect. So this is a synthetic sequence of a woman falling asleep at the wheel for the task of drowsiness detection, for example. And with Datagen, you receive synthetic annotations for each and every frame. So for each and every frame, you have the key points on her face, which is something that is practically impossible when it comes to human annotations. Kostya, you can close it. That's it. I'm going to summarize. I don't know if I've gone over time, but this is my last slide. What did we talk about? I explained when do we need annotations, why humans are the best, but they also have limitations, and why synthetic annotations are better than the best. I would like you to finish this talk with the urge to go out there and try synthetic data. That's whether it's Datagen or not, of course it's preferable, but still try it out because the power is unbelievable. And that's it. Thank you. You had a question.
So the synthetic data, the synthetic labeling is annotating synthetic data. How the synthetic data affects the model?
Do the models perform in the same way on synthetic data and real-world data?
If they learn synthetic data, how it affects the real-world data?
That's a great question. We are working on multiple research efforts to show that synthetic data is able to improve models. The first white paper, the one that I mentioned here, shows that when you mix synthetic and real data in a certain amount, the model actually improves. So there is no harm in using it, as long as you know how to mix. But again, some pre-processing will probably be required because there is a domain gap. Cool, thank you. Thank you for having me. It was wonderful.